Welcome back, everybody, for another deep dive with us. This time, we're heading out to Jupiter's moon, Europa.
Ooh, Europa.
Europa. Now, this is, it's a prime candidate in the search for life beyond Earth, right?
Absolutely.
You've shared some really interesting research and articles on this with me, and I can't wait to unpack it all with you. $5 billion, though. It's a $5 billion mission to Europa.
It is.
So there's got to be something really, really special about this moon, right?
There is.
Yeah.
What's so fascinating about Europa is that it really challenges our preconceived notions about where we think life might exist.
Okay.
It's smaller than our own moon.
Okay.
And it orbits Jupiter, which is, as you know, a gas giant.
Yeah.
Way beyond what we would traditionally think of as the habitable zone.
Right.
And the surface is basically just a giant ice skating rink.
Really?
Bombarded by radiation from Jupiter.
Oh, wow.
So not exactly a welcoming environment at first glance.
No, definitely not beach weather out there.
No.
But there's something about that giant ice skating rink that has scientists really excited.
Right.
And I keep seeing this idea of a hidden ocean beneath the surface of Europa.
Yeah.
Is that really possible? And what makes them think that there's an ocean under there?
It is possible.
Okay.
And the reason why we think that is because of the Galileo probe,
Galileo.
which orbited Jupiter from the late 90s to the early 2000s.
Okay, yeah.
And one of its key instruments was a magnetometer,
A magnetometer.
which is designed to measure magnetic fields.
Okay.
Now, you might be wondering what that has to do with finding a hidden ocean.
Yeah, it sounds more like something you'd use to find buried treasure, not an ocean.
Well, it's all about the subtle interactions between magnetic fields.
Okay.
So imagine a massive ocean of salty water
Okay.
underneath Europa's icy surface.
Okay.
Those dissolved salts would be conducting electricity.
Yeah,
Yeah.
salt water conducts electricity. I
Right.
remember that from middle school science class.
Exactly. So, but how does that create a magnetic field?
Yeah, exactly.
Well, whenever you have moving electrical charges, it creates a magnetic field.
Okay.
So this salty ocean sloshing around under the ice
Mm-hmm.
would be generating its own magnetic field.
Okay.
Now, remember, Europa is orbiting Jupiter, which has a very strong magnetic field of its own.
Uh-huh. So you're saying that ocean's magnetic field would interact with Jupiter's magnetic field,
Exactly.
and Galileo could pick that up.
Exactly. And that's precisely what Galileo observed. Strange deviations in the magnetic field around Europa that couldn't be explained unless there was a large conductive body of water beneath the surface.
Oh, wow.
It was a major breakthrough
That's incredible.
in our understanding of Europa.
So it's not just a guess. There's actual scientific evidence pointing to this hidden ocean.
Right.
But wait, I read something about plumes of water erupting from Europa's surface.
Right.
What's the story there?
Yeah. Now that's where it gets even more exciting.
Yeah.
During some of its closest flybys of Europa, Galileo detected these massive spikes in the magnetic field.
Okay.
And these spikes coincided with observations of plumes of water vapor shooting up from the surface, like giant geysers.
Wow. So not only does Europa have a hidden ocean, but it's also actively spewing it out into space.
It appears so.
That's mind-blowing.
It is.
But hold on, you mentioned earlier that Europa is bombarded by radiation from Jupiter.
It is.
Wouldn't that be a problem for any potential life?
That's a great question.
Yeah.
And it's true. The radiation levels on Europa's surface are incredibly high.
Yeah.
However, that same radiation might actually be playing a crucial role in creating the conditions that could support life.
Okay.
Here's how. When radiation interacts with water molecules in the ice, it can break them apart and create molecules like hydrogen peroxide.
Hydrogen peroxide, isn't that the stuff we use to clean cuts and scrapes?
Exactly.
Doesn't sound very life-friendly.
Well, in high concentrations, it's definitely not something you want to be swimming in.
Right.
But here's the key. Hydrogen peroxide is an oxidant.
Okay.
It can react with other molecules to form more complex compounds.
Okay.
And those compounds, in the right environment, could be the building blocks for life.
Oh, okay.
So the radiation is kind of a double-edged sword.
It is, yeah.
It's dangerous on the surface,
Yeah.
but it could be creating the ingredients for life in the ocean below.
I'm starting to see why scientists are so intrigued by Europa.
Right.
Yeah.
And there's another factor at play here. Tidal forces.
Okay.
Just like our moon causes tides on Earth,
Yeah.
Jupiter's massive gravity exerts this powerful pull on Europa.
Oh, okay.
And this gravitational tugging creates friction within Europa's interior, generating heat.
So you're saying that Jupiter's gravity is basically giving Europa a good internal massage, keeping things warm and toasty for any potential life in that ocean.
You could put it that way.
Okay, I like that.
Now, we still don't know exactly how much heat is being generated,
Right.
how thick the ice shell is, or the
Yeah.
precise composition of the ocean.
Right.
But all signs point to a potentially habitable environment.
Wow.
And that's why the Europa Clipper mission is so important.
All right. So we've got a hidden ocean,
Yes.
potentially warmed by tidal forces, maybe even enriched with ingredients for life thanks to radiation.
Potentially.
And now this Europa Clipper is going to investigate it all.
It is.
This is getting really interesting.
It is.
But before we dive into the mission itself, I'm curious, what kind of life could even survive in such a strange and extreme environment?
That's the million-dollar question.
Yeah.
And honestly, we can only speculate at this point.
Okay.
But scientists have some ideas based on what we know about extremophiles here on Earth.
Extremophiles,
Yeah.
those are the tiny creatures that thrive in really harsh places.
Exactly.
Like the ones that hang out in like volcanic vents
Exactly.
or super salty lakes.
Exactly. We know life can exist in some pretty wild conditions here on Earth.
Yeah, that's true.
So it's not inconceivable that something similar could have evolved on Europa.
Yeah.
Imagine microorganisms living around hydrothermal vents
Okay.
on the ocean floor, powered by the heat from Jupiter's tidal forces.
Or maybe even creatures that have adapted to survive in the ice itself,
Possibly.
using the radiation as a source of energy.
It's certainly possible.
Wow.
And that's why the Europa Clipper mission is so thrilling.
Yeah.
It has the potential to reveal a whole new world of life, unlike anything we've ever seen before.
This is seriously blowing my mind. I can't wait to learn more about this mission and what it might discover.
Well, get ready for a wild ride. The Europa Clipper is packed with cutting-edge technology designed to answer some of our biggest questions about this mysterious moon.
Okay.
Speaking of challenges, getting the Clipper to Europa is a feat in itself. It was originally intended to launch on NASA's Space Launch System,
Oh, the big one.
the big one. But budget cuts and delays forced a change of plans.
Okay, a change of plans. Now you've really got my attention. Tell me more about this Europa Clipper and how it's going to navigate the perils of deep space.
Oh.
So the Clipper was supposed to ride on the SLS, but now it's hitching a ride on a Falcon Heavy.
Yeah.
What does that mean for the mission?
Essentially, it means the journey just got a lot longer
Okay.
and a lot more complex.
You're complex. How so?
Instead of a direct shot to Jupiter, the Clipper will have to take a more roundabout path,
Okay.
using the gravity of Mars and Earth
Okay.
to slingshot itself towards its final destination.
It's like taking the scenic route, but on a cosmic scale.
Right.
I imagine this also affects the timeline of the mission.
It does.
By how much?
The original plan was to reach Jupiter in about 3 years.
Okay.
With the switch to the Falcon Heavy, it'll likely take around 6 years.
Wow, 6 years. That's quite commitment. But I guess when you're traveling across the solar system, a few extra years is just a drop in the cosmic bucket.
Right.
So the Clipper finally makes it to Jupiter, then what? Doesn't it have to deal with those intense radiation belts you mentioned earlier?
It does, and that's where things get really tricky.
Okay.
If the Clipper tried to orbit Europa directly, the radiation would fry its sensitive electronics in a matter of days.
Oh, wow.
So to avoid this, the spacecraft will orbit Jupiter in a highly elliptical path,
Okay.
swooping in for close flybys of Europa every 14 days,
Okay.
and then retreating to a safer distance.
It's like playing a cosmic game of tag with Jupiter's radiation belts.
Yeah.
Get in, grab the data, and get out before you get zapped.
Right.
But even during those brief flybys, wouldn't the radiation still be a problem?
It would be, which is why the Clipper has a special shield
Oh, really?
called the Vault.
The vault?
It's essentially a heavily fortified safe
Okay.
made of thick aluminum that houses all the spacecraft's critical electronics.
So it's like a high-tech Faraday cage.
Yeah,
Blocking out all that harmful radiation.
exactly. And it's not just a simple box.
Okay.
They had to carefully arrange all the components inside the vault to minimize weight
Okay.
and maximize protection.
Wow.
It's like a cosmic game of Tetris,
That's pretty intense.
with the fate of the mission riding on every placement.
Talk about high stakes. Okay, so we've got this incredibly resilient spacecraft braving the perils of deep space, dodging radiation belts. But what about the science?
Right.
You mentioned earlier that the Clipper is packed with cutting-edge instruments.
Yes, it is.
What can you tell us about those?
Well, remember how the Galileo probe used a magnetometer to detect the evidence of a hidden ocean?
Yeah, the whole salty water conducting electricity thing.
Right, the Clipper will have even more advanced magnetometers,
Okay.
which will allow scientists to map Europa's magnetic field in much greater detail.
So they'll be able to confirm the existence of the ocean,
Yeah.
determine its salinity,
Yes. Yeah.
and even get clues about its depth and structure.
Exactly.
It's like using a giant metal detector to scan a hidden world beneath the ice.
A very apt analogy.
Then there are the cameras,
Yes.
which will capture stunning high-resolution images of Europa's surface.
Yeah.
These images will help scientists study the dynamics of the ice shell, looking for cracks,
Right.
ridges, and other features that might indicate geological activity.
Exactly.
It's like getting a bird's-eye view of Europa, but with details so sharp you might even be able to spot a European ice worm if they exist, of course.
You never know.
But what about seeing through the ice? That's got to be the real challenge, right?
Absolutely. And for that, the Clipper has an incredible instrument called ice-penetrating radar.
Now that sounds like something straight out of a sci-fi movie.
It does.
How does that work?
It's surprisingly simple, in principle. The radar will send radio waves down through the ice
Okay.
and measure how they bounce back.
Okay.
By analyzing the reflected signals, scientists can create a map of the ice shell's thickness
Okay.
and even see what lies beneath.
It's like taking an ultrasound of Europa.
It is.
We'll finally be able to see what's going on in that hidden ocean.
Exactly. And remember those plumes of water vapor we talked about?
Yeah, those were pretty wild.
The Clipper has an instrument specifically designed to analyze those.
Okay.
It's called a dust analyzer.
A dust analyzer.
And it's essentially a high-tech particle catcher.
So it's going to fly through those plumes and try to catch some of that European ocean spray.
It will.
What will that tell us?
It will tell us a lot about the composition of the ocean.
Okay.
By analyzing the particles, scientists can determine what kinds of molecules are present, which will give us clues about the ocean's chemistry
Okay.
and whether it could support life.
Wow. It's incredible to think that we'll be able to sample the ocean of a moon orbiting Jupiter without even landing on it.
I know, it's pretty amazing.
Okay. We've covered the shield, the cameras, the radar, and the dust analyzer. Are there any other cool gadgets on board the Clipper?
Oh, there's one more detail I think you'll find quite intriguing. It has to do with how the Clipper is powered.
Okay.
You see, most deep space missions rely on a special type of nuclear power source called plutonium-238.
Right. I've heard about that. That's like a space-age battery that just keeps going and going. Exactly.
But the Clipper isn't using plutonium, is it?
You're right. The Clipper is powered by solar panels.
Solar panels.
30 meters of them, to be exact.
Wow.
It might seem strange to use solar power so far from the sun,
It does.
but there's a fascinating story behind this decision.
Okay, now you've really piqued my curiosity. Solar power all the way out at Jupiter. That's almost counterintuitive. What's the story there? Solar panels at Jupiter. It seems like it would be pretty dim that far out. Why wouldn't NASA use plutonium for a mission as important as this one?
Well, for a long time, plutonium-238 was the go-to power source for deep space missions.
Okay.
It's incredibly reliable.
Yeah.
Generates a lot of power,
Yeah.
regardless of how far you are from the sun.
Right.
But there's a catch.
Let me guess. It's not exactly easy to come by.
You got it. Plutonium-238 is a byproduct of nuclear weapons production.
Oh, okay.
During the Cold War, the U.S. had a surplus of it,
Okay.
which NASA used to power missions like Voyager and Cassini.
Right, right. Yeah, those are the classics. But after the Cold War ended, plutonium production dropped significantly,
Okay.
and NASA started facing a shortage.
So it's like their supply of space batteries started running low.
Exactly. That's why missions like Juno, which is currently orbiting Jupiter, had to go solar-powered.
Okay.
And the success of Juno, along with other solar-powered missions like Rosetta, which explored a comet, showed that it could be done.
Okay, so the Clipper is following in Juno's footsteps, proving that solar power can work even in the outer solar system.
Right.
But wouldn't a nuclear-powered spacecraft be more robust, able to explore even further and for longer periods?
That's a great point, and it gets to the heart of a debate about the future of space exploration.
Okay.
On the one hand, plutonium is still the gold standard for long-duration missions. It's incredibly reliable. It's not affected by things like dust storms or eclipses, which can interrupt solar power.
Yeah, that makes sense.
On the other hand, it's expensive, difficult to produce, and there are always safety concerns, especially during launch.
Yeah, of course. So it's a trade-off between reliability and practicality.
Exactly.
Yeah.
And that's why NASA's investing in both plutonium production and the development of more efficient solar technologies.
Oh, okay. So they're hedging their bets.
Right.
Working on both.
Exactly.
So the Clipper's decision to go solar isn't just about making the best of a difficult situation.
It's not.
It's also about pushing the boundaries of what's possible with solar power in deep space.
Exactly. And it raises a really interesting question.
Okay.
As we venture further out into the cosmos, what will be our go-to energy source?
Right.
Will it be nuclear, solar, a combination of both, or something entirely new that we haven't even imagined yet?
Ooh, the possibilities.
I know. It's exciting to think about.
This whole deep dive has been an incredible journey. We've explored the mysteries of Europa, learned about the challenges and the incredible technology behind the Clipper mission, and even touched upon the future of space exploration itself.
It's pretty amazing. It really highlights how much there is still to learn and discover out there.
It does. So as we wrap up this episode, what's the one thing you want our listener to take away from all of this? What's the so what
Yeah.
of the Europa Clipper mission? Why should we all be paying attention to a spacecraft exploring a moon orbiting Jupiter?
Because the discoveries this mission could make have the potential to change our entire understanding of life and our place in the universe.
Oh, wow.
What if the Clipper finds evidence of life on Europa?
Yeah.
What if we're not alone?
It would be a paradigm shift, wouldn't it? A moment that would forever alter our perspective on life as we know it.
Absolutely. And even if the Clipper doesn't find definitive proof of life, the data it gathers will still be invaluable.
Okay.
It will help us understand the formation of icy moons, the potential for habitable environments beyond Earth, and the incredible diversity of worlds that exist right here in our own cosmic backyard.
This has been an amazing deep dive. Thank you so much for sharing your expertise and insights with us. And to you, dear listener, we hope this journey has inspired you to keep looking up, keep wondering, and keep exploring the endless possibilities of our universe. Who knows what incredible discoveries await us out there? This is The Deep Dive, signing off.